Good afternoon, everybody. Today I'm going to present a project which is called Snake. It is a very simple game which is invented by us. The rules is just shown in the figure. The red lines indicate the first player and the blue lines indicate the second player. Two players take turns to play. And then you can see that the simple rule is that the lines cannot cross each other. So that the green circle indicates that when the red lines go to the dead end, the second player cannot find a way out. The second player will lose. So we need to define the maximum step which allowed the player to move each step, which can be in general any number. And SP is denoted the starting point of the game, which can be at any place. To make sure that the board can be played, we need to make sure that the board is interconnected, which means that it's one piece. So the right figure means that it's not interconnected. And BD is denoted the board, which can be in any shape. And it is finitely large and is also interconnected. In our project, to facilitate effective communication and to make sure that our idea can present clearly, we need to have so many definitions. But I'm not going to talk about all of this, but to pick some most important definition. So I'm not going to talk about neighbor function because it's just shown in the figure and it is very simple. But I'm going to talk about grid, which is generated by a single point x, which is shown in the figure. It's generated by the formula below. And in the figure, the red tiles indicate the grid generated by x. And all the elements inside the grid, we call it critical point. And loop is also very important because player can form loop after moving sometimes. And a loop is just defined as usual that every element inside the loop is connected to two other elements. And the area inside the loop, we call it part within loop. The outline is just the line circulating the board, and that it is not belong the board. And if the outline is interconnected, the board, we call it simply interconnected. That means that the board cannot have any hole in this if the board is simply connected. And inline is just the line subscribing the outline. It is the outermost line of the board. So in this figure, the red line is the outline and the blue line is the inline. And twisting point is just located in the inline, which is the corner of the board. And then shape 1-1 means that the board must be interconnected, which means that there are no holes in it. And all the twisting point is also a critical point. In this figure, the blue line is the inline. And the red tile is the twisting point, which is at the corner of the board, and which is also labeled as an C, which is also a critical point. Fulfilling these two properties, we call this shape 1-1. And then enemy grid is just the neighborhood of the grid. So in this figure, the red tiles indicate the grid, and the blue tiles indicate the enemy grid. And then I will jump all the definition, and I'm going to talk about what we find. We find that because this game is very complicated, we find a specific case. We call this case 1. And in case 1, the second player must win. Case 1 means that the maximum step must be 1, and the board is S11. And also the grid is generated by the starting point. So whenever the first player does, the second player can choose to move a critical point whenever he can. And we are going to prove that if he cannot do so, a loop must exist. And then when a loop exists, the second player can go inside the loop. And the spirit of our project is going to prove that the area inside the loop is also S11. And the most important property in this is that the board is only composed of 3 colors only. The red one is the grid, and the blue one is the enemy grid, and the white one is neither of them. The other property is less important. And then I'm going to talk about our proof of the strategy. So because that I need to emphasize this is not a loop because of the right part that the red lines stick together. So it is non-trivial that to prove a loop must exist. First thing is, whenever second player moves, a loop cannot be formed. Only first player formed loop because second player only goes to the red tiles, which according to the figure, the red tiles, the diagonal of the red tiles is also must be a white tile, so that a loop cannot be formed in this figure. So only first player make loops. And whenever a loop is made, the second player can choose to go inside the loop. And the area inside the loop, we call it a new board, BD star. And we need to generate a new board, a new critical set, a new critical point, which is denoted by pink color. So when combining these two figures, we can actually find out the figure become like that. The red color indicates the original critical point, and the pink color indicates the new grid. And the white color means neither of them is actually the enemy grid of the both grid. So we are going to prove that the area inside the loop is also S11, and we are going to prove it by contradiction. Suppose it is not S11, so there exists a twisting point which is not pink in color. That means that there exists a twisting point which is not a critical point. So we suppose T is orange in color. But it is impossible because by the nature of the board, orange in color T, the diagonal of it must be pink in color. But notice that because outline is made up of red and white only, so it is impossible for T that the diagonal is pink in color. So T must be white in color, but it will still lead to a contradiction because one must find that all its neighborhoods color, and we can assume that its neighborhood, whether its neighborhoods is belongs to the new board or belongs to outside of the board, and we will find that no matter the neighborhood of them is belongs to inside or outside the board, it can't be the T cannot be white in color. So T must be pink in color. So in this case, we have proved that the new board is also S11. And the second player can play it inside the new board. And it's go back to the strategy one that the second player can just follow the grid to play. So that whenever the first player makes loop, because the board is finitely large, the loop will become smaller and smaller. And that is the ultimate loop, which is a square. And when the first one make a loop, the second player step inward, then the first player lose. So in conclusion, we find that in this specific case, we call it case 1, second players must win. And I need to emphasize that case 1, it is allowed for the board to be any shape. The only matter is that all the twisting point is also a critical point. And actually in our project, we also find somehow we call it case 2 by cutting method. But I'm not going to discuss it here because it is less general. But I need to say that for every rectangular shape board, actually we find out all the general solution for this game for maximum step 1, because players can move only one step in our assumption. So thank you very much.